What is color? The science of light isn't just for scientists. Everyone uses it, even artists. We talked about how light is part of the electromagnetic spectrum, and that light is the visible part of the spectrum. One of the most interesting aspects of visible light is color, and artists know more than a thing or two about color. If you've ever seen a rainbow, you've probably seen all of the colors of light. They are red, orange, yellow, green, blue, indigo, and violet. Lots of people remember those colors using an acronym, which is an easy way of remembering the colors using the first letter of each color, Roy G. Biv. All of those colors make up the color spectrum, and each color represents a small change in frequency within visible light. When you see what we call white light, what you are actually seeing is all of the colors of the rainbow mixed together. A prism is a uniquely shaped object that can separate white light into individual colors. Artists use 3 primary color pigments, which are all opaque, to create all of the other colors. The primary colors of pigments are magenta, cyan, and yellow. Put together equal amounts of all 3 colors and you get black. By mixing together varying amounts of those colors, they can create orange, purple, and just about anything else you can imagine. Light comes in 3 primary colors too: red, blue, and green. And just like with those pigments, those colors can be mixed to create any color. Put all 3 of those colors together in equal amounts and you have white light. So, we know what colors are. They are different frequencies of visible light. But how exactly do we see them? Well, it goes back to the properties of reflection and absorption. When you look at an apple, you see red because red light reflects off of the object. All of the other colors are absorbed by the apple. When light hits something white, all the colors are reflected. When light hits something black, all the colors are absorbed. So the color you see when you look at an object depends on which colors are reflected and which are absorbed. Believe it or not, reflection and absorption often determine your wardrobe. For instance, if it's really sunny and hot outside, you definitely wouldn't wear black clothing. That's because all the light would be absorbed by your clothes and would be turned into heat. Put on something white that reflects light, however, and you're likely to be cool as a cucumber. As you can see, light makes it possible for us to do ordinary things like reading a book at night, watching television, or coordinating our wardrobe. And it makes it possible for us to do extraordinary things like creating spectacular fireworks shows. Light, it makes everything brighter in the real world.